welcome to my channel Learn Math. In this session, we are going to find the values of p and q, the coefficient of x square and x in the given polynomial if x plus 1 and x minus 2 are factors of this given polynomial. So the first step in solving the synthetic division question is to write the given polynomial p of x in the standard form. The given polynomial x cube plus px square plus qx plus 6 is already in the standard form. The second step is to find the zeros of this given polynomial. So the given roots, the given factors are x plus 1. So we will equate it to 0. And from here, x is equal to minus 1 is 0 of the given polynomial, and the other factor is x minus 2. We will equate it to 0. So x is equal to 2 is another 0 of the given polynomial. In step 3, we will write the coefficients of the given polynomial. So coefficient of x cube is 1, coefficient of x square is p, coefficient of x is q, and the constant term is 6. Now we will draw the synthetic division table, and on the left hand side we will write the first 0, which is minus 1. Now this first coefficient is written down as it is, so we have 1. Now this is multiplied with the 0 value is minus 1, so 1 multiplied with minus 1 is minus 1, and that is written under the next coefficient of the given polynomial. Now we will perform addition of these two, and the result is p minus 1. Now this term is then multiplied with the given 0, and the result is written under the next coefficient, which is q. So p multiplied with minus 1 is minus p, and minus 1 multiplied with minus 1 is plus 1. And we will perform addition of these two. So q minus p plus 1. Now we will multiply the given 0 with this term, and the result will be written under the next coefficient, which is a constant term. So q multiplied with minus 1 is minus q, minus p multiplied with minus 1 is plus p, and plus 1 multiplied with minus 1 is minus 1. And now we will perform addition of these two. So we have minus q, we have plus p, and minus 1 plus 6 is plus 5. Now this last term is a remainder. Now this is the quotient which is obtained by the dividing given polynomial x cube plus px square plus qx plus 6 by the factor x plus 1. So the coefficient q of x in this case will be x square, as this polynomial is divided by x plus 1, so the quotient power will be 1 less than the highest power of the given polynomial. So highest power of this polynomial is x cubed. So the highest power of the quotient will be x square, and the next factor, which is p minus 1, will be quotient of x, and the last factor, which is q minus p plus 1, or the last term, that will be the constant term. And minus q plus p plus 5 minus, or this is remainder, which is minus q plus p plus 5. Now, as q plus 1 is factor of the given polynomial, so this remainder must be equal to 0. So we can write that 0 is equal to minus q plus p plus 5. So this is one equation that we have derived from this division. Now, we know that a polynomial p of x is equal to the factor, which is x plus 1, multiplied with the quotient q of x. Or we can write that the quotient of a polynomial p of x can be obtained using the factor division. If the p of x is divided by x plus 1, then we will get the quotient. So we can obtain the same polynomial from that quotient and the factor. Now we can see that x plus 1 is not divisible by x minus 2. So for the next division, we will have this quotient q of x will be divisible by the next factor x minus 2. So we will perform the second division by using this quotient q of x, which is x square plus p minus 1 into x q minus p plus 1. So we will write the coefficient of this quotient, which will be a polynomial, which will be our polynomial for the next division by the factor x minus 2. So we will take 1. The other coefficient is p minus 1, and the constant term is q minus p plus 1. Now we will draw the synthetic division table, and the next zero value is 2. So we will write is equal to 2 on the left hand side. Now the first coefficient is written as it is, which is 1. Now this 1 is multiplied with the value of 0, which is 2, and the answer is written under the next coefficient. So 1 multiplied with 2 is 2. Perform addition of the 2. So p and minus 1 plus 2 is plus 1. Now we will multiply this term by the value of 0, which is 2, and will write the result under the next term, which is q minus p plus 1. So 2 multiplied with p is 2p, and 2 multiplied with 1 is 2. Now perform addition of the 2. So we have q in the bottom and no q in the below. So we have q, and minus p plus 2p is plus p, and 1 plus 2 is 3. Now this last term is remainder of this synthetic division. So according to the given condition in the question that x minus 2 is a factor of the given polynomial, so q plus p plus 3 must equal to 0. So this is our second equation. So we will add equation 1, which can be rewritten as minus q plus p plus 5 is equal to 0. We will add this equation 1 and equation 2. So adding equation 1 and 2, we have minus q plus p plus 5 is equal to 0, and we have q plus p plus 3 is equal to 0. Q cancels out with q, and we have 2p, and 5 plus 3 is 8 is equal to 0. So we have 2p is equal to minus 8 by taking 8 to the right hand side. Now dividing both sides by 2, we have p is equal to minus 8 by 2, which is equal to minus 4. So the value of p is minus 4. We will insert p is equal to minus 4, insert p is equal to minus 4 in equation 1. So we have minus q, and for p we have minus 4, and we have 5 is equal to 0. So minus q, and we have plus 1 is equal to 0. Take take 1 to the right hand side. So minus q is equal to minus 1, minus cancels with minus, and q is equal to 1. So p is equal to minus 4 and q is equal to 1 are the required values. Now we have we have used two tables to perform the synthetic division. This division can be performed using a single table. So let me rewrite the coefficients of the given polynomial, which are 1, p, q, 6. We will draw the synthetic division table. The first 0 is minus 1. So write first coefficient is, it is 1, multiply minus 1 with 1, write the answer under the next term. So 1 multiplied with minus 1 is minus 1. Add the 2, p minus 1, multiply it with the 0 value, which is minus 1. Write the result under the next term. Minus 1 multiplied with p is minus p. Minus 1 multiplied with minus 1 is plus 1. Add the 2, so we have q minus p plus 1. Now perform multiplication with minus 1 and write the result under the next term, which is the constant term. So q multiplied with minus 1 is minus q. P multiplied with minus 1 minus p multiplied with minus 1 is plus p. We have plus p. Plus 1 multiplied with minus 1 is minus 1. Add these two. So we have minus q plus p, and minus 1 plus 6 is plus 5. So this is one remainder. From the division of the first factor, now we will perform the second division, because this is the polynomial for the second division, for which the factor is, here the factor is x plus 1, and now the factor is x minus 2, for which the 0 is x is equal to 2. So the first coefficient is written is, it is 2 multiplied this 1, and the answer is or the result is written under the next term. So 2 multiplied with 1 is 2. Perform addition. P minus 1 plus 2. So minus 1 plus 2 is equal to plus 1. Now multiply it with the value of 0, which is x is equal to 2, and write the result under the next term. So 2 multiplied with p is 2p, 2 multiplied with 1 is 2. Perform addition of the 2. So we have q, and 2p minus p is p, and 1 plus 2 is 3. So this is the second remainder. This is remainder number 1, and this is remainder number 2. So according to the given conditions, what are the conditions? That x plus 1 is a factor and x minus 2 is a factor. So for x plus 1 is a factor, remainder 1, which is minus q plus p plus 5, must be equal to 0. This is our equation number 1. And for the second condition, x minus 2 is a factor, remainder number 2, which is q plus p plus 3 is equal to 0. This is our equation number 2. So we will add equation 1 and equation number 2. Minus q plus p plus 5 is equal to 0. Q plus p plus 3 is equal to 0. Q cancels out with q. We have 2p plus 8 is equal to 0. And from this, we have 2p is equal to minus 8. Take 2 to the other side. So we have p minus 8 by 2. 8 divided by 2 is 4. So value of p is minus 4. Insert p is equal to minus 4 in equation number. We can put an equation 1 and in equation 2. The previous we have put it in equation 1. Now let's put it in equation number 2. So we have q, and for p we will write minus 4 plus 3 is equal to 0. So we have q minus 4 plus 3 is minus 1 is equal to 0, which implies that q is equal to 1. So required values are p is equal to 4 and q is equal to 1. Hopefully this is easy to understand. If you like the video, please subscribe the channel. Thank you.